Okay, a lot of people are learning stoichiometry right now, so I want to show you my 3-step process to perform stoichiometry. So step 1 is to convert into moles. Step 2 is to do your BCA table or mole ratios, and step 3 is to convert to your final units. Now, if you don't know how to do one of these components, I suggest you go back and watch another one of my videos. Second note, not every teacher does a BCA table, but I really like them because they set you up with all the information you could need to answer any part of any stoichiometry question. So we're going to do a practice problem now and go step by step. So I know this is small, but if a 0.25 gram sample of magnesium is placed in 10 grams of water, what volume of hydrogen gas will be formed at STP? Assume a complete reaction. And then here's the balanced equation. You've got magnesium solid is reacting with 2 waters to form magnesium hydroxide and hydrogen gas. Small note, this wouldn't happen actually at standard temperature. This water would need to be hot, but we're just going to pretend that it does for the sake of looking at some stoichiometry with mixed units here. So step 1 is to convert to moles, and because we were given 2 starting amounts, so we were given 0.25 gram samples of magnesium and we were given 10 grams of water, we need to do this step twice. So you always start with what's given, and we're going to set this up in 2 different conversions. So 0.25 grams of magnesium from the problem, and then we're going to divide by the conversion factor. So this, because we're starting with mass, we're going to use the molar mass. So the molar mass of magnesium is 24.3. And you're going to divide. So 0.25 times 1 divided by 24.3. And that is going to give you, for magnesium, 0.01 moles. For water, you're going to do 10 grams, always start with what you're given, divided by 18.01, which is the molar mass of water. And when you do that math, you're going to get 0.55 moles. So now, as I mentioned, I like to do the mole relationships in a BCA table. So BCA stands for before, change, and after. So before you begin, you have these amounts that you just calculated right here, and so you just match them under the reaction. So you got 0.01 moles of magnesium, that's what you're starting with before your reaction, and then 0.55 moles of water. Before you begin, you haven't made any products because the reaction hasn't happened, and so that's always going to start with 0 and 0. And then you need to choose your limiting. So you can do what I call a guess and check, and you want to make an educated guess. So my educated guess here is that this is going to run out and go to 0 because it's much smaller than this. And so that's often a safe bet. So if that runs to 0, it's going to look like that and be 0.01. It would all be used up, and it would go to 0, and that would make it the limiting reactant. So now we need to check that by doing the math with the mole ratio. So I need 2 waters for every 1 magnesium. And so in order to do that, I would need to do 0.01 times 2 divided by 1. And that would give me 0.02. And so then the question is, does that math work, or does it give me a negative number? And it works. And so that means we chose the correct limiting reagent, and then the water is in excess at an amount of 0.53 moles. So now that we know this is your limiting reagent, all the rest of your math will revolve around this value, the change line of the limiting reagent. And so we're going to use our mole ratio again. So for every one of these, we need one of these. And for every one of these, we need one of these. Again, these relationships come from the coefficients. And so you're going to have the 0.01 moles of magnesium hydroxide and 0.01 moles of hydrogen. And this is how we did that calculation to go to there. And then to go from here to here, it would just be 1/1. So then my third and final step is just to convert to your final unit, so you're almost home free. So you're going to take, it asks us to find the volume of hydrogen gas at STP, so we're going to take our mole amount for hydrogen gas, which is 0.01, and we're going to put that there, and then you're going to multiply that by the molar volume of a gas at STP, which is 22.4, and you get your final answer of 0.224 liters of hydrogen gas. So there you go. 3-step process to stoichiometry. Works every single time. Oh, quick note. Sometimes you might be given substances in moles and then you would skip step 1. Sometimes you might want the answer in moles and then you would skip step 3. But you always do the mole ratio here. You have to do that in order for it to be stoichiometry.